Hello everyone. In this video, I will talk about the singleton design pattern. I will first explain how static variables work and then how these static variables, together with the don't destroy on load function, can be used to implement the static pattern inside Unity. Singleton pattern is one of the most useful and widely used pattern. The two main properties of a singleton class are that it has just a single instance and it has a global point of access, which means any other script can directly access variables or fields inside that singleton class. In the context of Unity, this makes them very suitable for creating manager scripts in your game. For example, your game manager, score manager, time manager, etc. We can also use the singleton pattern for data persistence between scenes. Let's first talk about how data or variable are stored in the memory. This will help you understand how static variables work and how the singleton pattern is implemented inside Unity. So any variable or function that you create inside Unity is allocated some location inside your computer memory. So for example, your float A will correspond to or point towards a memory location. Your variable B will point towards or refer to a different memory location. And for a simple operation, let's say adding A plus B equal to C. For this operation, what actually happens is that the computer will take the value stored in this memory location, which is the float A, then take the value that is stored at this location in the memory, add them both together, and then push it or save it at the location which corresponds to the float value C. This type of memory allocation and these variables referring to a particular memory location holds true also for classes. In the case of classes, classes are just a pattern or definition or how your data and function are clubbed together. The classes on itself won't be assigned a particular memory location, but when we create an instance of a class, so for example, I have a class named gun. It has two variables, a float and a string, and if I create an instance of this gun class, let's say gun1 and gun2, at the creation of a instance of the class, which is also called an object, a particular memory block would be assigned to this class, and for each of the variables stored inside the class different memory blocks will be assigned. So for example, for my first object gun1, the float value will correspond to a particular memory location. For my next object of the same class, its float value will be assigned a different memory location, and both of these variables gun1 dot value and gun2 dot value don't point to the same thing, so both of them can be different. My gun1 dot value can be 3 and my gun2 dot value can be 5. In short, every object will have its own copy of the variables. So gun1 will have a copy of the variable value and string, gun2 will have a copy of its own value and string, and likewise every other instance created will have its own copy of those variables. But when we come to the static variables, every static member inside a class will have just a single copy, and every instance created of that class will refer to the single copy that corresponds to a particular class. So in this example, if I have a class gun and now I have made my float value to be of the type static, so this class will create a single static copy, a single memory location for my float value, and every instance created after that will all refer to this single particular memory location. This means all these instances don't have their individual copy of the float variable, but they share the variable. This also means that if you make a change, if a single instance or a single object makes a change to that static variable, and since the variable is shared between the instances, then all the other instances will also be affected by that change. To give you a small example, suppose this float value, the static float value corresponds to my ammo, and I have three guns in the game. But since the ammo value is a static, if one of the gun changes the ammo value from 10 to 5, the rest of the guns will also have their ammo changed to 5 because they all refer to the same variable. They won't have their individual ammo values. With that in mind, now I will show you how you can implement the singleton pattern inside Unity. Now there are lots of ways to implement this singleton pattern. First, I will show you how you can use just the static variable that I have just shown you to fulfill one of the criteria of a singleton class, which is a global point of access. A global point of access will mean that any script inside your scene will have a direct reference to that class. So you can use it for your game manager, sound manager, or your score manager, and any script in your class. Those are the game objects can directly call a function or get value from that single manager class, which is implementing one of the features of the singleton pattern. So here I have this singleton object which has a singleton test class. Now I want this class to be directly accessible to every other script in the scene. So what I can do is first create a static variable of the type singleton test, and this static variable is what other scripts will use to access this class. So I will create public static singleton test, and generally it is named as instance. And inside my awake function, I will just assign the instance to this class. This means my current singleton test class, which is assigned to the singleton test game object. We are doing this assigning operation inside awake because other scripts may use our class in their start function, and awake is called every time before the all the start functions, so we can be sure that if anyone is using our singleton test class, then we have already assigned a reference to our class. Let's also create a test function inside our singleton class so that we can test how other scripts can access this singleton class. Public void test function, and we will simply debug a message to test that our singleton is working. Now to call this function from outside the script, let's just create a new script which will try to access that singleton class. So let's name it test, and we can assign it to any game object in the scene, it doesn't matter. And what this test singleton function will do is simply try to call the function which is inside the singleton class. To access any member of our singleton class, what we can do simply is to write the name of our singleton class and then go to the static instance of that class, singleton test.instance, and this will give us access to all the variables and fields of our singleton class. So in this case we are trying to call the test function in our start, so when the game starts we will directly call the test function inside our singleton test. You will notice that this new game object from where we are calling our singleton function has no reference of the singleton class. It is a global point of access. Anybody can call that function. When we go into the play mode, you can see that we get the debug message that singleton is working. But this only fulfills one of the criteria of a singleton class, that it provides us with a global point of access, which is sufficient for creating game managers or score managers. But if you want to transfer data or for data persistence between scenes, you also want the second property of a singleton class, which is that there should only be a single instance of our singleton class. And there are again lots of ways to achieve that. I will show you one popular way of achieving a single instance of our singleton class. So this is the code block that ensures there is just a single instance of the singleton class. I will shortly explain how this works, but the feature that I showed you earlier, the global point of access, will still remain the same. So you can still directly call the singleton test dot instance and call the test function. This method uses the don't destroy and load unity function, and this function ensures that whenever a new scene is loaded, a particular game object is not destroyed. Now, taking the example of a single scene reload, that means you have a particular scene, you destroy everything in that scene, and the same scene is again reloaded. This can be useful in the cases of game restart. Now, if I have my singleton class in that scene and I have marked it as don't destroy and load, if you do a scene reload, you can imagine that we will create duplicates of our singleton test game object, and the rest of this method just combats that duplication and ensures that we have just a single copy. I will explain it more clearly in a simple diagram. So let's say this is our simple singleton class with a single static variable of the same type as our class, which is called instance. And suppose if we start in the first scene and there are no duplicates of my singleton class, we are the single one in that scene, then in that case we will go to inside our first if function, and we will mark our game object as don't destroy and load, which means that we are the real copy of the singleton class. Don't destroy us when a new scene is reloaded, and then we will assign ourselves to the static instance variable, so that and all of this is done inside awake. And after we have assigned us to the instance variable, other scripts are now able to refer us and access us. Now imagine we go into a scene where duplicates of our class exist. So for example, we come from this scene to this scene, and there are other duplicates lying around in that scene. What will happen here is that as I explained how static variables work, on that scene, every static variable of the type singleton will refer to our singleton 1 class, which has been assigned in the previous scene. In our first singleton 1 class, which is carried from the previous scene, the awake function will never be called because it is not newly generated game object. But on all the other duplicates, what will happen is that this instance is referring to the singleton 1 class. So what will happen is that instance will not be equal to this, it will be equal to the singleton 1 class. So this code block will be called, and all this will ensure that all the duplicates are destroyed, and the only one remaining is the single singleton class. Now when we have a singleton class which has a global point of access using the public static instance, and we can be sure that there is just a single instance of that class, we can use this singleton class as our game managers. And we can also use this with the help of the don't destroy and load function to pass data between different scenes. So you can pass player information, his score information from the game scene to your menu scene, and etc.